Now let's look at learning objective D, and I'm going to introduce to you vocabulary about functions that are increasing or decreasing and positive or negative. Let's first talk about what increasing and decreasing means on a function. If a function is increasing, means the slope of a line on the particular interval is positive. If it's decreasing, it means the slope of the line on the particular interval is negative. And we're going to answer these questions in interval notation. So here's the first one. Consider this polynomial right here. By the way, third degree polynomial, leading coefficient is 1, the constant value is -2. And let me show you the sketch of what that looks like. Here's what the graph would look like. Now here's what they're telling us. A relative maximum occurs when x is equal to approximately -1.3. So we're talking about right here is where we see our relative maximum at -1.3. And then a relative minimum occurs when x is a positive 1.3. So something right over here. Now what they want us to do is describe the intervals where it's increasing and where it's decreasing. Now, by definition, for a function to be increasing means the slope is positive. So right here, we see the slope is positive in this interval and in this interval. So what we're going to say for increasing is we're going to talk about it in terms of the x's. We want all the x values less than -1.3. So x is less than -1.3. But then we want all the x's greater than 1.3. So I'm going to say x is greater than 1.3 is where it's increasing. Now the decreasing is where the slope is negative, and we can see that that's happening right here. And that looks like it's in between -1.3 and positive 1.3. So for the decreasing part, let's go down here. The x's are in between -1.3 and positive 1.3. Now notice I did not use the equals to signs here because when you're at these particular points, the slope at that point is flat. It's neither increasing nor it's decreasing. Same thing here, when you get to this point, it's flat and there's no difference in the slope. Okay, let's continue on. This time I want to add 2 more vocabulary words. Let's talk about what it means to be positive and negative. To be positive means the y's are greater than 0, and to be negative means the y's are less than 0. So the positive is going to be above the x-axis, and the negative is going to be below the x-axis. So if we get some colors out and highlight this, let's talk about where the function's positive. It's going to be positive from here to here. And it's going to be positive all the way up here. And then it's going to be negative from here all the way down, and from negative from here to here. So I'm going to box that in the purple. So if we have to state the interval for where it's positive, what I need to know here, it looks like, are the x-intercepts. So I would have to find the x-intercepts or the zeros for that one and state them accordingly. Now I don't have it right in front of me, but let's go ahead and get those values. Let's assume that this one x-intercept is a -2. And let's assume this one is about 0.2 and that this one is at +2. So where I would say it's positive, or the green section of this graph, is between -2 and 0 and the 0.2. So let's state this as an interval, and I'm just going to say the x's are in between a -2 and then a 0.2. But it also continues because there's a second part, so I need all the x's greater than 2. Now again, when they sit on the axis here, the answer is 0, which is considered neither positive nor negative, so I do not include the equals to on those. All right, let's look at the negative. This function is negative anything less than -2. So I'm going to say it's the x's less than -2. And then it's also negative between 0.2 and +2. So we'll just say between 0.2 and positive 2. Now I want us to look at another example using the vocabulary, but instead of using the numbers, we're going to use letters and talk about the intervals. So we have here a fourth degree polynomial, leading coefficient, negative 2/3, no constant value. They want us to identify the interval where it's negative and then decreasing. So negative, remember, means that the y values are negative. So this thing is negative here, here, and here. So to state those as intervals, what we would do for where it is negative is we would say we're looking at the x's that are less than the letter A. So any x that's smaller than whatever A is. And then I want any x's in between C and E. So x's are less than C and less than E. And it does need to be in this order. C is a smaller number than E is. You can tell where it falls on the number line. And then the last part is I need all the x's greater than G. So here, greater than G, or all the x's this way. Now, where is the function decreasing? Remember, decreasing means the slope is going negative or downhill. So it looks like from here to here, and then from here to here is the decreasing. So I can tell the x's are in between the letter B and letter D. Then the x's are F and anything bigger than F. So let's write this one as the function decreases as x is in between B and D. And then anytime x gets greater than F, because notice the F is there, the x's get bigger, this thing is decreasing. And that's our final answer. Now this side question here is interesting. It's asking us what is the behavior between E and F. If we look at E and F, if you had to give a vocab word of E and F, I would say a couple behaviors. It's positive between E and F, but it's also increasing. So it's a combination of both on that. Okay, let's look at our last example for the other two vocab words. A different graph with the same concept. Where is the interval where this is positive? So remember, positive by definition means you're above the x-axis. So here, here, and here. So it looks like we're looking at the x's between A and C, the x's between E and G, and the x's greater than I. So if I write that down, the x's are between A and C. The x's are also in between, it looks like E and G. And then we said the x's are greater than the letter I. Now, where is this function increasing? Remember, increasing means the slope is positive. So it's positive here, it's positive here, and it's positive here. So I would state that, again, it looks like anything from B on lower. It looks like it's between D and F, and between H on up. So I'm going to say all the x's less than B, the x's in between D and F, and the x's greater than H.